Hello guys, once again, welcome back to Med Zone African Motives. We are still on the continuation of our exponents, okay? Working with our exponents. If we check previously, we worked with only a single condition whereby we're just focusing with the same base, the same base, the same base throughout. Okay, now we have a condition of these typical questions whereby this time you are working with the different bases or you are working with the same bases throughout, but having a separated part. So you're going to start first with the first part, which is our A, which is a revision from our grade 9 mathematics. Remember, we talked about this type of a question. All right, number one, we are given 3 to the exponent of 4 being multiplied to 3 to the exponent of 5 over 3 to the exponent of 2. So in these types of questions, we are going to focus on major laws. The two laws that we're going to focus with is of a to the exponent of m multiplied to a to the exponent of n. We are going to have a to the exponent of m plus n. We add our exponents. And the second one on the division part of a being raised to the same exponent of m, but this time divided to b to a, sorry for that, to a to the exponent of n, because we are maintaining the bases that are the same. Is going to be a to the exponent of m minus n. All right. So on a condition like that, it means the first part that I'm having here, I'm considering 3 and 3. Okay? 3 and 3. They are the same. So what am I going to do? I'm going to add the exponents. Why? Because I'm multiplying. So if I'm multiplying, I'm going to add the exponents. So the exponent there is a 4 and a 5. So I'm going to have 3 to the exponent of 4 plus 5. All right? Everything over 3 to the exponent of 2. I'm going to explain how to combine them at once, okay? Everything over 3 to the exponent of 2. So here on top, we're going to have 3 to the exponent of 4 plus 5, which is a 9, over 3 to the exponent of a 2. Okay? We can subtract now because we are dividing. We are back to the division part. Are they the same, the bases? Yes, they are. We've got 3 and 3. So what are you going to do? We are going to subtract the exponents under the same base of a, which is 3. So that's 9 minus 2, which is going to give us 3 to the exponent of 7. Yes, you can simplify if you want 3 times 3 times 3, or at the end, you can even just use your calculator there. You're already on the final answer. So you can just even simplify 3 to the exponent of 7, which is going to give you 2,187. So this is 2,187. Okay, so meaning to say we can simplify these typical questions whenever they are being separated that way. So it's the same scenario that we have on number 2. You can try it. All right, but if you see now, there are extended questions where we can see the exponents being different, like what we have on number 7. All right, like I said, this is just a recap of our grade 9. So let us just see number 7. You can try other questions and see if you're having, if you're giving or obtaining exact values for any part that you have a confusion. What you do is that this is how you prove your answers. You simplify like this. All right, let us take an example of question 4. All right, you put on your division like this. I'm just showing you how you can prove your answers. 2 to the exponent of a 5, sorry, 2 to the exponent of a 5, all right, multiplied to 2 to the exponent of 4. Remember, you're on number 4, 2 to the exponent of a 4 over 2 to the exponent of 3 in bracket. So you're going to open a bracket, 2 to the exponent of a 3. Okay, you move this and you close the bracket, you raise to the exponent of a 2 like this. You can get the answer, which is 8. So it means if you use our laws, our rules, whatever that we have, and you are not obtaining 8, that answer is wrong. And if it is wrong, let me know. All right. So that's what I'm trying to say. You can prove this on your calculator because I'm not going to answer all of these questions. So you can just, every question that we have here, you can use your calculator to prove what you are getting on your calculator. What you get on your calculator is exactly what you are supposed to obtain. All right. Anyways, let us focus on number 7. Number 7 is a little bit different. I just need to explain one or two things on this one. Also, you can use it to answer any question that you be given. 2 times 5 to the exponent of a 3 over 2 times 5 to the exponent of 2 multiplied to 5 to the exponent of a 3. All right. In some cases, they might not give us expanded for us like this. They might just give us as a 10. Remember, 2 times 5 is 10. So this question was supposed to be asked as, they were supposed to give us this question as 10 to the exponent of 3 over 2 times 5 to the exponent of 2 times 5 to the exponent, like this. You are the one who is supposed to now expand this 10 in as a product of its prime factors. So you expand this as a product, all right, as a product of its prime factors. Remember your prime factors from your mathematics grade 9, okay? So what are the prime factors of 10? The prime factors of 10 can be taken the smallest. Remember, the first prime factor, the first prime number is 2. These are the numbers that you divide by 1 and itself. So 2 is a prime number. Most of us, we confuse on that 2 because it falls under even numbers also. 2 is a prime number, okay? And that's the smallest prime number that we have. 1 is not a prime number, okay? 1 is an odd number. So the difference that we have is that we say 2 is the first prime number, so you're going to divide 2 into 10. 10 divided by 2, that's 5. The other prime number that you can use, we are now having 5. We cannot use a 2 like this one. We cannot use a 2. 2 cannot be divided into 5, so you're going to use a 5. 5 is a prime number. So this is 10 is same as 2 times 5. That's why you see here they wrote 2 times 5 for you. They wrote it, but in most cases, they won't do that. That's why I'm explaining this. So you write this as a product of its prime factors. Once you write it as a product of its prime factors like this, like what we can see here, 2 and 5. All right, now let us apply our laws. Remember from our introduction, we said, if a bracket is being raised to a certain exponent, it means all terms will be raised to the exponent that is outside. That is 2 to the exponent of 3 times 5 also raised to the exponent of 3. Everything will be raised to the exponent of 3. All right. Everything over 2 times 5 to the exponent of 2 times 5 to the exponent of 3. All right. Now let us get back to our laws. Like I said, okay, I actually forgot to explain how to do it direct on that question. But anyways, let me explain it on this one. What you do is that here you consider where the bases are the same. Here it's 2, which is same as 2 to the exponent of a 1. So we've got a 2 here that we have to consider, which we are dividing. So when we are dividing and these bases are the same, so what are we going to do? We are going to subtract. All right, let's hope I did not remove those laws. All right, here we are going to subtract. Okay, because we are dividing, we're going to subtract. So meaning to say here, we are going to subtract on 2, we are going to subtract because we are dividing. So that's 2 to the exponent of 3 minus 1, which is a 2. All right, on 5, you do the same thing. This part is 5 to the exponent of 3 on top. Okay, but this one, these ones there, they are multiplying each other. But if I'm to consider that I'm dividing, what do? I subtract the exponent. So it's going to be 3 minus this exponent, which is 2, minus this exponent also, which is 3. So it's going to be minus 2. I subtract also this exponent because they are all in the denominator. So I subtract them, all of them from what? From 3. So that means we are going to have at the end 2. All right. So let us see here. 3 minus 1, which is a 2. So that's 2 to the exponent of 2 multiplied to 5 to the exponent of, we can subtract 3 minus this 3. As you can see, this one, it gives us a 0. So what are we going to have at the end? We're going to have a negative 2, or you can subtract 3 minus 2, which is a 1. Then 1 minus 3, which is a negative 2 in that case. So in this case, we are obtaining a negative exponent, negative 2. Remember, we talked about a condition where you obtain a negative exponent, that when it is in the numerator, you write it down in the denominator. Remember our laws, we said x, or let us just say in terms of a to the exponent of negative m over b to the exponent of negative m, or negative n. Let's use n here. We're going to write this as b on top to the exponent of n, a below to the exponent of m. Take note, this one, it was on top, now we write it in the denominator. This one was below, now we write it on top. So meaning to say, in order for us to change this, we're going to write it below as, so it's going to be 2 to the exponent of 2. So you're going to have this, you're going to have this one, 2 to the exponent of 2 over 5 to the exponent of 2. 2 to the exponent of 2 is not having a negative exponent, so it remains as it is on top. This one will be written below, so we can simplify. 2 to the exponent of 2 means 2 times 2, which is a 4, over 5 to the exponent of 2 means 5 times 5. It multiplies itself 2 times. So 5 times 5, that is a 25. So that is how we can be able to simplify such typical questions. So our answer there was going to remain as 4 over 25 in simplest form. Okay, so like I said, you can prove that on your calculator. If you are working this alone, you want to check that your answers are correct. This is what you can do. Just use your calculator to prove this. Put a fraction, 2 times 5, open a bracket, 2 times a 5. Like this, everything to the exponent of a 3. Okay, you go down, you multiply as it is. So it's 2 times 5 to the exponent of 2, all right, times 5 to the exponent of a 3. So this is going to give us 4 over 25, which is the same answer that we got here, 4 over 25. So that means if you are working there, you can prove this one with your calculator. So I want you to do that, prove your answers to see if you are in the right direction. Then if there is any question, let me know so that we can work on that question together, as I want us to focus on this because this is the major part of your syllabus for grade 10. All right. We are still on the same situation that we were working with on those previous questions. But this time we are working with most of our questions with a variable on the exponent, with x, a variable on the exponent. The idea there is not going to change, okay? The idea is not going to change even if the exponent is the one that is carrying a variable. Let's take a closer look on first question, 2 to the exponent of x multiplied to 2 to the exponent of x. We are considering that these two are the same, all right? The bases are the same. What are you going to do? We know that we add the exponents because we are multiplying the same bases. So we're going to add our exponents. There is x and this one is x. So it's going to be x plus x. So we are back to our normal algebraic expression. When we are adding x plus x, what does it mean? It means 1, and there's a 1. So it's 1 plus 1, which is 2x. So this will be 2 to the exponent of 2x. So this one, there's nothing I can do. I just have to leave it like that. I'm done, all right? That is how we can apply these laws. Let us check another part. Number 2, let's also direct this one. Remember from our laws, we said if there is a number, okay, we have got a to the exponent of m raised again to the exponent of n is going to give us a to the exponent of mn, which is m times n. It is the same situation here. There is an exponent that we have on this number. So what does this part mean? It simply means I'm going to multiply this exponent 5 times x, which is 2 to the exponent of 5x. Right? Done like that. The same thing on this one. X and 3 multiplies each other. So it's going to be 3 to the exponent of x times 3 is 3x. All right, remember x3 and 3x are the same. It's best for you to start with a number, then followed by a variable, okay? So consider here, we are back again. The bases are the same, we are multiplying. So we're going to add the exponents, which is x and 3. So this will be 2 to the exponent of x plus 3. There's nothing we can do on that one. All right, but on number 5, we consider this, we are going to see that we have, okay, let me not remove this because we're going to need it. All right, let me just rewrite number 5 here because just need to explain 1 or 2 things there. 5 to the exponent of 3, all right, 5 to the exponent of 3 multiplied to 3 to the exponent of 5, then everything to the exponent of x. Our situation is not going to change because these two terms are multiplying. We are going to have the same situation, but remember this time, this must be raised to the exponent of x, and also this must also be raised to the exponent of x. So meaning to say we are going to have 5 to the exponent of 3 being raised to the exponent of x. Also, we are going to have 3 to the exponent of a 5 being also raised to the exponent of x. So it's an exponent and an exponent just like this, but m and n, you multiply m times n. So you're going to multiply 3 times x, which is 3x. So that's 5 to the exponent of 3x multiplied to 5 times x, which is 5x. So it's 3 to the exponent of 5x. These numbers here are not the same. So there's nothing I can do. Do not force a law where it does not apply. You now want to add these exponents. No, we can only add if these numbers are the same, the bases are the same. All right, so that means on this one, do not force any addition there. We are done on that question. That is how we're supposed to answer this one. All right, so that was our number 5. Let's see question number 6. All right, number 6, we have a situation just like what we considered from our previous class, where we can expand these two terms. All right, no problem. Let us consider this. From our grade 9, we talked about a condition where the bases might not be the same like what we saw in the previous case. They were not actually the same. There's nothing that we're supposed to do on that question. But this one, because you might be asking to say, but that one we didn't add. Okay, let's say we've got 7 to the exponent of 2x multiplying 2 to the exponent of 5x. No matter how you try your magic, no matter how you try your calculations, no matter how you try to transpose, no matter what, you cannot simplify this because the bases here are not the same. So your question now is, how now are you wanting us to work this one? But because you said they cannot be simplified. It's true, I said they cannot be simplified. But these ones that we see, they are a little bit different because this one, you can not even write it as a product of its prime factors. It's done 7, guys. It's just same. That's a prime factor that we have, this 7. Okay, if we were given a number here, maybe it's 14, all right, to the exponent of x. At least I was going to ask myself, okay, 14 there, how can I rewrite 14 as a product of its prime factors? Okay, this 14. So we understand that this 14 that we have can be written as 2 times 7. Okay, if it was like that, then at least I can think of expanding my question further. 7 to the exponent of 2x times 14, which we said is 2 times 7. So it's going to be 2 times 7 to the exponent of x. Everything raised to the exponent of x. Then I'm going 7 to the exponent of 2x multiplied to everything here now is going to be raised to the exponent of what? Of x. So we are going to see 2 to the exponent of x multiplied to 7 also to the exponent of x, like that. This is what you're going to see. So if it is like this now, we can see, all right, on this one, on this 2, there's nothing I can do, but on this 7, there's something that I can do. What is it that I can do there? I can add the exponents because I'm multiplying the bases that are the same. So on that situation, I can simplify it further. 7 to the exponent of 2x plus x multiplied to 2 to the exponent of x. There's nothing that I can do. I do not have anything that I can use, and it's already in simplest form. So I'm going to add this part now. 2 plus 1, which is 3x. So I'm going to have 7 to the exponent of 3x times 2 to the exponent of x. There's nothing I can do at this stage. I'm done. My simplification is done. So if you consider this is the same situation of our question here to say, yes, the bases are not the same, but there is something that we can do on this number, which we refer to as 9 here. It can be written as a product of its prime factors, in fact, in terms of 3, because 9 is same as 3 times 3. If we divide the smallest number, which is 3, 9 divided by 3, that's a 3. We divide again 3, 3 divided by 3, which is a 1. So meaning to say 3 times 3 gives us a 9. So if 9 is same as 3 times 3, what does it mean? If 3 is multiplying itself 2 times, it means it's 3 to the exponent of 2. Okay? So if this is 3 to the exponent of 2 representing 9, I'm going to take it back to 9. So this will be 3 to the exponent of 2 representing 9. But already there's an exponent which is there, which is the exponent of what? Of x. So I'm going to multiply that to x. Then I here 3 is already in simplest form. There's nothing I can do here. So I'm just going to rewrite as it is 3 to the exponent of what? Of 2x. So considering this, we can multiply because now we are back to the condition of an exponent and exponent. So we are going to multiply these 2 times x, which is 3 to the exponent of 2x, multiplied to 3 to the exponent of 2x. So what are we going to have at the end? I'm multiplying these bases, they are the same. So what do? I add the exponents together. So that means I'm going to have 3 to the exponent of 2 plus 2, which is 4x. So I add the coefficients of x, which is 2 and 2. So the answer is going to be 3 to the exponent of what? Of 4x. That's how our questions might be given as. All right, so that was our question number 6. Let us check the other part. On question number 7, we have got the same situation here. On question number 7, we can see that it is the same scenario that we had like this part. All right, let me just remove this part here. So number 7, we are given again, that's 81 to the exponent of x multiplied to 27 to the exponent of 2x. So in your own understanding here, you might see as if this cannot be simplified. If you check it, you say, no, the bases are not the same, so I cannot add, which is true. You cannot add these two here because these numbers are not the same. This is 81, this is 27. So if you know your numbers, you can see that 81 is same as 3 to the exponent of 4. All right, you can test your numbers. All right, how do I test? At least know this idea before I introduce you to calculate. At least know this idea. at least know that if I'm dealing with 81, 243, 9, 27, I'm working with 3. If I'm dealing with 8, 32, 16, 64, I'm working with 2. If I'm dealing with 25, 125, 625, I'm working with 5. If you know that part of your multiplication, it helps you now to trace back to say, which number am I going to use to the exponent of what to get 81. So if you know that it's related to 3, you are not going to have a problem. You just try on your calculator 3 to the exponent of 2, you get 9. You are not getting 81. You move on, 3 to the exponent of a 3, you get 27. You move on, it's not 21, it's not 81. You move on, 3 to the exponent of 4, you get what? 81. So meaning to say that you can say in place of 81, I have 3 to the exponent of a 4. So this is what you're going to have. 3 to the exponent of 4 multiplied. All right, there's an x here. Sorry for that. Remember, we still have this x here, this one. So you're going to have to multiply, to raise everything to the exponent of x. Okay, we do the same thing. 27, we saw when we were trying for 81, we saw 27, we got it at what? 3 to the exponent of 3. So it's 3 to the exponent of 3. Then everything to the exponent of what? Of 2x. Or you can go back to expressing these numbers as product of their prime factors. Remember, I talked about that from our mathematics grade 8. Yeah, that's what we talked about, product of prime factors, all right? So 81, the smallest number there we can think of is 3. All right, a factor of 81, you divide 81 divided by 3. If you do not know it, just use your calculator. All right, if you do not know this, just use your calculator to divide 81 divided by 3, you get what? 27. So this will be 27. We try again 3, we divide by 3. 27 divided by 3, we are going to get a 9. All right, we have a 9 here. We try again 3. Okay, so 3 can be used there. We divide by 3, we're going to get a 3. We also use a 3. 3 is a 1. So meaning to say we are now in simplest form. Now the question is, if this is 81, so how can we write it? 3 times 3 times 3 times 3. We said it represents to the exponent of 4. So it's 3 to the exponent of 4. How many times is 3 multiplying itself? 1, 2, 3, 4. So that's to the exponent of f4. So that is how you can work it from this. If you consider 27, there's no need for you to start, because 27, you can see it here. 27 is here. Is 3 to the exponent of what? 1, 2, 3. 3 to the exponent of 3. But if you know it by head, then just write your answers, okay? If you know it from the calculator, use your calculator to check which one exactly represents the one that you are referring to as 81 in terms of 3, which one that you are referring as a 27 in terms of 3 also. So these are the typical approaches that you are going to have in your syllabus, actually working with these typical questions of this nature. So let us see. Let us see here. Now we can expand. Remember, I talked about the idea of an exponent to an exponent. This is what we have here. So you're going to multiply m times n. So that will be 3 to the exponent of 4 times x, which is 4x, multiplied to 3 times 2, which is 6x. Right? So that's a 6x there. 3 times 2, that's 6. At this stage, that's where now you can add your exponents, because you can see that the bases are the same. A to the exponent of m multiplied to a to the exponent of n. We add the exponents when it is like this. We are multiplying the same bases. So now we can do that. But previously, we couldn't do that because they were different. But by simplifying, we can later on have same bases like we can see. So now we can add 3 to the exponent, we add 4x plus 6x, 4 plus 6, which is 10. So this is going to be 10x. That's the whole situation there. That's the whole situation that you're going to have. That's how you are supposed to attempt these typical questions. So as you can see, this is now in simplest form. So that was our question number 7. let's see question number 8. Question number 8. All right, it's the same thing also on question 8. There we are given 5 to the exponent of x multiplied to 5 to the exponent of x, everything over 25 to the exponent of x. Again, we cannot simplify this, but on top, yes, on top we can do that. On the numerator here, we can add because the bases are the same. We can add 5 and 5, add our exponents. Remember I said this is same as 1x, this is same as 1x. So we can add 1 plus 1, which is 2. So you're going to have 5 to the exponent of 2x. But what about this one? Can it be added? No, it cannot be added. It cannot be subtracted. There's nothing that we can do. They are different. But before you conclude to say, this is my final answer because I cannot, because these two numbers are not the same. Before you conclude that, I said, simplify your questions, all right? So think of 25, because 5 is a prime number on its own. So there's no way we can write it as a product of another prime number to give us a 5. It's already a prime number, this one. So we think of 25. It's not a prime number. So which numbers that you multiply to get a 25? So that's 5 and 5. Or you can go back again as a product of its prime factors. You start with 5. 25 divided by 5, that is 5. We divide again by 5, which is 1. So 25 is same as 5 times 5. But if 25 is same as 5 times 5, it means 5 to the exponent of 2. It is multiplying itself 2 times. So thus this 25 that we see here is going to be written as 5 to the exponent of 2x, which is this one on top, over this one. We are going to write it in terms of 5 to the exponent of x. But, sorry, to the exponent of a 2 here, 5 to the exponent of a 2. All right? But whatever that we have, we must raise it because there's an exponent that we already have here, which is x. So it's 5 to the exponent of 2, representing 25, which is this one. But what about the exponent x that we had? We're going to have to write it aside here. So now you are back to the condition that you have got an exponent and an exponent. You multiply them together. So that will be 5 to the exponent of 2 times x, which is 2x. Okay, considering these two terms, we can subtract because the bases here are the same. So you can just subtract because we are dividing. So that's 5 to the exponent. If we subtract these two, 2x minus 2x, that's a 0, right? So that's 2x minus 2x, which is a 0 there, okay? So this is just going to give us a 0 there. And we know that any number, when raised to the exponent of 0, it gives us what? A 1. So meaning to say the whole of this question was going to give us a 1 at the end. Okay, so as you can see, that's how our questions might be given as. Just have to be careful in your simplification. Just consider your prime factors, know them. Like I said, revise also your mathematics for grade 9. It is very, very important that you know those basics. So if you've got time, in fact, you must have time to go back to your grade 9 and revise again. Just not to go back to that level, but just go to the notes and check one or two things there. All right, number 9, we've got the same situation that we have to consider these laws again. 2 to the exponent of x is being raised to the exponent of 3, then multiplied to 2 to the exponent of x, everything over 16. All right, in our normal analysis and looking into the question, we can see that on the top, yes, we've got 2, but there are some things that have to be simplified, an exponent and an exponent. Before we talk about the combination of this, let's consider this first. So meaning to say, you're going to multiply because there's an exponent and there's another exponent there. So it's going to be 2 to the exponent of x times 3, which is 3x. Now multiplied to 2 to the exponent of x, which is in simplest form. But what about 16? What am I going to do with 16? 16 is the same as 2 to the exponent of a 4. All right? 2 times 2 to 4 times gives us a 16. Or like I said, you test on your calculator, you know that you're dealing with 16, so you can try at least working with 2, all right? Not 3, guys, but 2. 2 to the exponent of 3, you get 8. You see that, okay, it's not the 1. You move on, 2 to the exponent of a 4, you get 16, like that. So that is how you can actually get your answer if you do not understand how to get it direct with your normal evaluation. But it's one and the same thing, as you can see. But this 16, it is being raised to the exponent of x. So we are going to raise this, our 16, which is 2 to the exponent of 4. Remember, this is our 16 now. It's only written in terms of an exponent. So that's to the exponent of x. So we're going to multiply an exponent and an exponent again, 4 times x, which is 2 to the exponent of 4x. So what does it mean? It means this whole part of 16 to the exponent of x, when being simplified, it is going to give us 2 to the exponent of 4x. Okay. Last time I explained about simplifying this on top, then you simplify this one below after. But this time I want us to combine these, our laws, together at once. Let us combine them. Okay, on top, what is happening? We are multiplying the bases. These are the bases which are the same. So what are you going to do? We are going to add our exponents, 3x plus x, okay? But what about here? What is happening? We are dividing this time. We are dividing. So if you are dividing, what do? You subtract, because they are also the same, our bases there. But you have to subtract. So instead of you working first 2 to the exponent of this, you get your answer 2 to the x over 2 to the x, like what we did previously, to say we get an answer, then at the end we apply the laws. No, we can apply all of the laws at once, right? Because the base is the same throughout. So I'm just going to combine my numerators. I add because I'm multiplying. To the denominator, I'm going to subtract the exponent because I'm dividing there. So this gives us a little bit fewer steps to apply. We've got fewer steps because you're just going to add 3 plus 1, which is 4, all right? Then 4 minus 4, 4x minus 4x, that's a 0. So you're going to obtain 2 to the exponent of 0, which gives us a 1. Remember, any number to the exponent of a 0, it gives us what? A 1. That's how we can play around with these questions. So guys, as we can see, we cannot finish all of these questions. You need to revise also as an individual to understand how these questions are given and so forth. Even if you've got negative exponents, remember, we talked about a condition of a negative exponent. Let us consider number 13 as our last question. Then I want you to try other questions where you have your challenge, any challenge on these questions that I left. Do them, try them. Where you have a challenge, let me know on the comment section so that we can do that question together. All right. On number 13, we are given 12 to the exponent of x. This is 12 to the exponent of x multiplied to 3 to the exponent of negative x. Okay? Everything over 2 times 4 to the exponent of x. Okay, there are so many ways, platforms, like how to answer this. There are so many ways that we can do. Okay, of all those ways, that you can consider, I want us to take first the negative. Let's get rid of this totally before we talk about any simplification. Let's get rid of this total, this negative exponent. Let's remove it totally. How do you remove it? Remember, I told you, if you have a negative on top, you write it down as a positive exponent. If you have a negative exponent down here in the denominator, you write it on top as a positive exponent. So here we've got a negative in the numerator on top. So we just drop it down, it becomes a positive. So that's going to remain with 12 to the exponent of x over, we have dropped this down, so you're going to remain with the 2 times 4 to the exponent of x times the 3 to the exponent of x that we dropped down here. So it is going to be 3 to the exponent of a positive now. So at least now I can relax and work my question because I know I'm just working with positive exponents. I'm not having negative this and that. It's just positive throughout. Okay, remember that we cannot simplify this further because here we are considering a 12, which we do not have a 12 here. But as a product of its prime factors, let us go back to 12, all right? 12, as a product of its prime factors, the smallest number that we can use is 2, okay? You divide 12 divided by 2, which is a 6. You divide again by 2, 6 divided by 2, which is a 3. Again, this time I'm going to use 3. So 3 divided by 3, which is a 1. So it means 2 times 2 times 3. It gives us a 12. So if it is that the case that 2 times 2 times 3 gives us a 12, what is 2 times 2? 2 times 2 means 2 to the exponent of 2. Then 3 is just a single term, so it's just going to remain as a 3. So if I multiply this 2 to the exponent of 4, I get 12. I get 4. Then 4 times 3, which is a 12. Okay? So this gives you a 4 times 3. It gives you a 12 everything. So meaning to say this could have been written as 2 to the exponent of 2 times 3 in place of 12. In place of 12, writing this in simplest form and everything raised to the exponent of x. Okay, over, you're going to do the same thing on 4 here. So it's going to be 2 times this 4 that we see. We have to write in simplest form. So remember, 4 is same as 2 times 2, which is 2 squared. So it's going to be 2 to the exponent of 2, but everything is going to be raised to the exponent of x. Okay, multiply to 3 to the exponent of x, which is already in simplest form. So this is already in simplest form. So we can simplify now here. So remember the concept. If I'm given an exponent here, and there's an exponent, I'm going to affect it. So this will be raised to the exponent of x. 3 will be also raised to the exponent of x. So it's going to be 2 to the exponent of 2 to the exponent of x like this. This one to the exponent of x. So remember, we multiply these two. So it will be 2 to the exponent of 2x. Okay? Then this one, 3 raised to the exponent of x is just going to be 3 to the exponent of x. Okay? Everything over, let's simplify in this part. 2 multiplied by 2 times x. Again, we've got an exponent and an exponent, so you're going to multiply. So it's 2 to the exponent of 2x times 3 to the exponent of x. So at this stage, there's nothing that I can do. So what I can do here is to just combine where I can be able to combine, all right, the basis of x and so forth. I mean, the basis of 2 and so forth, all right? This is, there is a 1 here, 2 to the exponent of 1. So from the law that I just talked about, I said, if you are having the bases that are the same, we can subtract, but here we've got 2 to the exponent of 1. So you're going to subtract 1, which is our exponent. Also, we've got 2 to the exponent of 2x in the denominator. So you're going to subtract that 2x, okay? Then multiply to the same on 3. We are dividing, so you're going to subtract. So it's 3 to the exponent of x minus x. And that's a 0 there, all right? X minus x, sorry. So meaning to say, you're going to simplify 2x minus 2x, it gives us a 0. So you're going to remain with 2 to the exponent of 1. Multiplied to this one, it gives us a 0. X minus x, that's a 0. This is 1 minus 1, which is 3 to the exponent of, which is same as 1. All right, any number to the exponent of -1 simply means 1 over that number. So it's 1 over 2 times 3 to the exponent of a 0, which is what? Which is 1. So we can multiply 1 over 2 times 1. Remember that any number times 1 remains as it is. So it's going to remain as 1 over 2 at the end. So there we have applied our laws up to the last stage of our simplification, up to the last stage of our simplification. So if we are to simplify, we have to be very, very careful. Simplification, you have to be very, very careful. How to use your laws? Application of your laws, all right? You have to apply your laws carefully. All the laws now combined together from our grade 9, grade 8. So I want you to revise those laws, okay? Revise these questions, work them out. If there are any questions with any challenge, let me know so that we can work on those questions separately as we are revising our basics, the introduction, so that we prepare ourselves for the question papers, because very soon we shall be working with question papers, questions from question papers, so that you'll be able to understand how do they ask these questions. But this is what is important in your introduction for exponents of this type of nature.